Hi, this is Kurt with Dog Eat Dog Games, and I'm here to do another tutorial on our AudioVisualizer tool. In this tutorial, I'm going to show you how to do beat anticipation as well as create improved performance by using pre-recorded audio tracks. Be sure to see our other tutorial on recording audio. If you haven't seen that one yet, definitely watch it before this tutorial. Anyways, moving forward, if you go under Assets, AudioVisualizer Scenes, and under Beat Anticipation, we're going to show you how to use an audio file to trigger events before a beat is detected. So let's go ahead and hit play here so you can see what's going to happen. So what this scene is basically doing is just launching balls, and it wants them to hit these cubes when a beat is detected. And the only way we could do that is if we knew when the beats were going to happen ahead of time. So to make this effect happen, under the audio sampler, under audio files, we need to drag in an audio file that we've recorded. And we're going to want this to sync up with the audio source. So if you have, this is the pop dance clip, and this is the pop dance, this is the file that we recorded using this audio clip. Then the next thing you want to do is check out this audio file event listener. So this works exactly like the audio event listener, except the audio file event listener reads data strictly from this file, and the audio event listener, like you probably know already, does runtime data. So if you're not familiar with this, definitely check out our other tutorials, and they go over the audio event listener, how to use that a little bit more. But basically, in this tutorial, I want to talk about the audio file event listener. And the only thing that's really different about this is this pre-beat offset. So right now this is set to 1.5, which means that 1.5 seconds before a beat is detected, we're going to trigger some events. So let me just show you how that looks like from the code. I have this little script called ball launcher, which launches all these balls. This script subscribes to audio file event listener.onBeatRecognize. So in your script, all you have to do is subscribe to this event and call your method. And here's the method that I'm calling. It takes a beat, and this beat class, let me show you that real quick. It basically just has a time that the beat was recorded and also a volume. So the volume is kind of like the intensity of the beat at that time. So what I do from the ball launcher class is basically I have an index. There's 5 different cubes I'm trying to hit and 5 different spawn points. So basically what I do is switch between, I either go up or down based on if the volume of the beat was greater than the last volume of the beat. So every time a beat is detected, I'm going to record the volume, and I'm going to say, is this volume greater than the last volume? If so, we want to move to this. If we were on this cube, we want to make a ball hit this cube. If we were on this cube, we want to go up and hit that one, etc. So that's just saying which ball we want to launch at which cube, and then this code just creates a ball and launches it. And I have this this launch set up to take the same amount of time as our pre-beat offset. So each ball takes 1.5 seconds to get to its destination, and that's how you sync up. I also want to show you, just in another scene, if you go to pre-recorded, you can also drive waveforms with pre-recorded audio tracks, and that's mainly used to increase performance. If you're doing runtime beat detection and runtime evaluation of the audio, that costs more than if you do it pre-recorded. So to use pre-recorded audio, I'm going to show you this line waveform. I've got 2 different ones here. Let me go in and hit play on this scene. We've got 2 of these line waveforms. And this waveform on the left is using runtime data, and the waveform on the right is using pre-recorded data. And we also have some beats being triggered, again, using pre-recorded beat detection and runtime beat detection. So the only difference on all of the waveform scripts is that we now have a parameter that says use audio file. If that is checked, then under audio sampler, it's going to use the audio file that's dragged in under the audio sampler instead of the audio source. And if you have multiple audio sources and multiple audio files, then the index that you're using is referenced here, this audio index. So that's basically it. All the waveforms operate exactly the same as they used to in our 1.0 version. We now just have this use audio file parameter, which is going to use the audio file instead of runtime audio evaluation. That does it for this tutorial. If you have any questions, you can check out our website, doggeatdoggames.com. Go under support, and at the bottom you can email us any questions you have. Also check out our other tools if you haven't seen them yet. We have a mesh tracer tool, which overlays particle effects on top of 3D models, and then a procedural spaceships tool, which creates randomly generated spaceships. All right. You can also ask your questions on Facebook and Twitter. That does it for this tutorial. Happy coding, and we'll see you later.